Okay, moving on to a new section, absolute value inequalities. So, if you were with me for a previous lecture when we dealt with absolute value equations, this section is similar, but we got a little bit of a difference because we got inequalities to deal with. Are you with me? Okay, so let's just dive into this. This one asks us to solve, and then it says to write the answer in interval notation. Well, no surprise, you have an inequality, you're going to write your answer in interval notation. But let's take a look. I do have absolute values, don't I? Which means you're going to actually have how many equations, or in this case, how many inequalities? Good, 2. Can I break it up into the 2 inequalities right now? Yes, you can. Excellent. Some of you listened to the last lecture. Yes, you can. Why? Because the absolute value sign is already by itself. So, remember, in this particular case, I am going to have, just like before, the positive of this 2x plus 7, and in this case, less than or equal to 13. But I can also have the negative of that 2x plus 7, still less than or equal to 13. Okay, let's go solve. Well, the positive sign isn't going to do anything, is it? So I have 2x plus 7 less than or equal to 13. Now what? Good, minus the 7 on both sides. So you have 2x less than or equal to 6. And last but not least, good, divide both sides by 2. You have x less than or equal to 3, don't you? Excellent. What about this one? Yeah, I don't want the negative sign here either. So just like we did before, we're going to multiply or divide both sides by this negative to get rid of it. Which means I'm going to have 2x plus 7. And on this side, it's going to be a negative 13, isn't it? But what happens to the inequality sign when you multiply or divide by a negative number? Excellent. It flips over. And there is where we have to be careful. In the last lecture, if you were with me with the last lecture, I mentioned that the whole reason I wrote it this way was because the inequalities were going to do something a little bit different than the equations. And the inequality sign was going to flip on us. Cool? Okay, so here we go, solving like we always do. Minus the 7 on both sides, we have 2x greater than or equal to negative 20, and then divide both sides by 2. X is greater than or equal to negative 10. Excellent. Okay, so help me out. Whether they tell you to or not, what do you always do before you write the interval notation? Good, you graph it, because the graph, or I should say the interval notation, is best written from the graph. So, I have the graph. What are the 2 numbers I care about? Yeah, I care about the negative 10 and I care about the positive 3. So let's take a look at this first answer. We have x less than or equal to 3. So, good. I'm looking at the 3 and I'm going to shade everything to the left of the 3. All the way out to negative infinity. And yes, a bracket goes on the 3 because it's equal to, isn't it? What about this one? X greater than or equal to negative 10. Good. So I am going to shade everything to the right of the negative 10, all the way out to infinity, and I'm putting a bracket on that negative 10. Now this is interesting, because in actuality my entire number line is shaded, isn't it? But then there's also an overlap, isn't there? Okay, you remember that lecture on overlaps? Yeah, that means intersection, doesn't it? Do you also remember in that same lecture there was everything shaded? Yeah, that was the union, wasn't it? You're like, so what do they want here? Do they want the overlap or do they want everything? Are they looking for the intersection or are they looking for the union? What are they looking for? Here's how you're going to find out. So I'm going to have you play along with me. This symbol is the less than symbol, isn't it? Right? That symbol is read less than, isn't it? Well, I'm going to do a little play on words to help us understand what they want here. I am going to rephrase it as less and. Do you remember what the word and means? Yeah, that word and means intersection, which means I'm looking for where the shading overlaps. Where does my shading overlap? It starts at the -10 and ends at the 3. And what are you going to put on these numbers? I'm going to put a bracket on both of them. Because, yes, bracket on both of them because here's a solid bracket and here's the shading. Here's the shading and there's the solid bracket. So those numbers are both in common. Okay. You know how to do all this. You know how to solve the inequalities. You know how to graph the inequalities. The real key here is understanding that this symbol read less than. If you change it and read it as less and, you know that you're looking for where these overlap. By the way, this only happens with the absolute value inequalities. Let me say that again. The only time you have to interpret this inequality sign is when there's absolute values in the problem. Write that down. Pause the video, rewind it a little bit, and then write down what I just mentioned. The only time you interpret this inequality sign is when there is an absolute value in the problem. Got it? Okay, hang in there. I'll be right back with another one. Okay, so let's look at the second problem. Do you see those absolute values? Good. So how many inequalities are we going to have? Good, 2. Do I break them up into the 2 inequalities right now? Excellent. You don't. Why? Because they're not by themselves. So what do you got to do first? You got to move the 7 over first. So when I move the 7 over, I still have the absolute value of z plus 2, and it's less than 4. Good. Now am I able to break it up into the 2 inequalities? Yes, I am. Good. So I have got the positive of the z plus 2 less than 4, but we also have the negative of the z plus 2 less than 4, don't we? Okay, let's go solving. The positive in front doesn't do anything. It's still z plus 2 less than 4. Moving the 2 over gives you z less than 2. Excellent. This one. Yeah, I don't want the negative sign there either, so what are we going to do? Multiply it to the other side, divide it to the other side, whichever one you want to do, we get the same result. Does the inequality sign stay the same? Nope. I just multiplied or divided by the -1, and so I have now z plus 2 is greater than -4. Get the 2 on the other side, z is greater than -6. Agreed? Okay. They want the answer written in interval notation, so what do we got to do? Yes, graph it. Whether they tell you to or not, you should always graph it. Remember, interval notation is best read from the graph. So I have -6 and I have +2. Remember, this is still a number line, so you better put the numbers in the right order. Okay, so this one, z is less than 2. Good, all the numbers to the left of 2 to -infinity, and this guy gets a parenthesis. And z greater than -6. Good, all the numbers to the right of -6, all the way to +infinity. And this one also gets a parenthesis, doesn't it? Okay, so I'm noticing there's an overlap. I'm noticing there's a union. What's going on? What do I want? What do they want? Yeah, go back to the beginning. Actually, go back to where the inequality sign, or go back to where the absolute values are by themselves. Don't go to the original. Go to where the absolute value is by themselves. On problem number 1, the original problem had the absolute values by themselves. So I was going to go back to problem number 1. On problem number 2, I had to move the 7 over. So I'm going to look at the second line where the absolute value is by itself. Got it? Okay, so you see this symbol? How do you read it? Yeah, you read it as less than. But remember the play on words? Yeah, less and, which means we are looking, that's right, for that intersection. We're looking for the overlap, right? Yeah, you have to remember that symbol means intersection. So where do they overlap? Yep, the overlap starts at -2, pardon me, the overlap starts at -6, ends at +2. What am I going to put on the -6? Well, some of you are debating. Some of you think you should put a parenthesis, some of you should put a bracket. Remember, overlap means they have it in common. This shading definitely passes through the -6. So the -6 is actually covered. But this one up here has a parenthesis, which means it's not used at all. So it doesn't overlap at the -6. I'm putting a parenthesis. What about at the +2? Same situation, parenthesis. One of them is shaded through it and the other one says put a parenthesis so it's not used at all. Got it? Hang in there. Got another one for us. All right, let's look at this next problem. See those absolute values? Yep, you're going to have how many of them? 2. Can I break it up into the 2 absolute value inequalities right now? Yes, you can. Excellent. Why? Because the absolute values are by themselves, so I can split it up right now. Excellent. So let's split it up. So remember, you're going to have the positive of what's inside here, greater than 2, but you're also going to have the negative of what's inside here, greater than 2, aren't you? Let's go solve the first one. Positive sign doesn't do anything, so I still have 9 minus x greater than 2. Then what? Minus the 9 on both sides, so you have -x greater than -7, and then, yeah, you're going to have to divide both sides by a -1 to get rid of that negative in front of the x, aren't you? Which means you end up with x is less than 7. Awesome, good job. What about this one? Yeah, get this negative to the other side. It's just simpler. So I have 9 minus x is what? Less than 2, because you multiplied or divided by this negative sign, which flips that inequality sign. Then what? Good. Minus the 9 on both sides. So I get -x is less than -7. And then x is greater than +7. Good. Does that make sense? Okay. Now what? Yeah, you're going to have to graph, because in order to determine the interval notation, you're going to have to graph this. So I guess the only number I care about is 7. All right. So according to this one, I want x less than 7. So that's all the way to the left to -infinity and a parenthesis. And on this one, I want everything to the right all the way to +infinity and a parenthesis. Now, you're like, well, what do they want? Remember, look where the absolute value sign is by itself, which is the original problem, and let's read this. This symbol is read what? It's read greater than, right? I'm going to play on the words a little bit. Greater than. Remember what that word or means? Yeah, that word or means union. That means it wants everything. That is shaded. So if I look at my graph, do you notice the shading starts at -infinity, which always gets a parenthesis, but the shading ends at +7, doesn't it? Because there's a parenthesis there, isn't it? But then it picks up again at the 7 with a parenthesis and goes to infinity, which always gets a parenthesis, doesn't it? Okay. What do I put between these two interval notations to make it one sentence? Because right now it's 2 and I need one answer. Yeah, you put the union sign. So my x's, because that's what I solved for, my x's are in this interval or this interval. Cool? Hang in there. Be right back with another one. Okay, we're back with problem number 4. Do you see those absolute values? How many inequalities will you have? Good, 2. Can I break it up into the 2 inequalities right now? No, you can't. Good job. Why not? Because the absolute values aren't by themselves. I got this plus 1 on the same side, so what are you going to have to do first? Good. Get that plus 1 to the other side. So the real problem is the absolute value of 10 plus 3x is greater than or equal to 1. Now can I split it up into the 2 inequalities? Yes, I can, because now the now the absolute values are by themselves. So I got the positive of the number inside. That's supposed to be greater than or equal to 1. But I also have the negative of the number inside. That's supposed... Whoops, I put the x with the wrong number, didn't I? Well, let's erase that first. Okay, but I also have the negative of the number inside. That's still supposed to be greater than or equal to 1. Agreed? Okay. Plus sign doesn't do anything, so this is just 10 plus 3x greater than or equal to 1. Move the 10 to the other side, so you have 3x is greater than or equal to negative 9. Divide both sides by 3. X is greater than or equal to negative 3. Excellent. What about this one? Yeah, let's get rid of this negative sign to the other side. So I have 10 plus 3x is less than or equal to negative 1. Then what? Move the 10 to the other side. So 3x is less than or equal to negative 11. And divide both sides by 3. X is less than or equal to negative 11 thirds. Awesome. You guys are doing great. Now what? Yeah. Now let's go graph it. Okay. 11 thirds. I need to see that as a mixed number so I know where to put it on the number line. Yeah, that's negative 3 and 2/3, isn't it? Okay, so that's smaller than negative 3. So here's the negative 3 and here's negative 11 thirds. Agreed? Okay, time to graph. X is greater than or equal to negative 3. That means all the numbers to the right of negative 3 all the way to infinity. And that's right, this guy gets a bracket. This one, I want all the numbers to the left of negative 11 thirds all the way out to negative infinity. And it also gets a bracket, doesn't it? Okay, how do I know what they want? Yes, look where the absolute value signs are by themselves. Let's get a different color. Okay, absolute value signs are by themselves there, right? So this symbol is read greater than, but we're going to play on the words and say greater than, which means union, means everything, right? Okay, it wants where everything is shaded, so let's take a look. Yeah, and I'm going to write the answer over here. So the shading starts at negative infinity, which gets a parenthesis, goes all the way to negative 11 thirds, which has a bracket on it, and then the shading picks up again at negative 3 all the way to positive infinity and a bracket on the negative 3. And what are you going to put in between those guys? Yeah, you're going to put the union symbol to keep the two individual answers together in one sentence. Does this make sense? How are we doing? Yeah, not so bad, right? Remember, the only time you interpret the inequality sign is when you have absolute values in the problem. If you got to write that down again, write it down again. Good? Hang in there, got it. So let's look at problem number 5. Do you notice we have absolute values? Good. So you have how many inequalities? 2. Excellent. Can I write the 2 inequalities right now? Yes, you can, because the absolute values are by themselves, right? Okay. But let's take a closer look at this problem. I have these absolute values that are less than or equal to a negative 3. Now, wait a minute. Absolute value means I'm dealing with what kind of number? Yeah, a positive number. and over here is a negative number. Is a positive number less than a negative number? No. Is a positive number even equal to a negative number? No. So is there any way that I could even solve this problem? No. So what's the answer to this problem? Yeah, this one's no solution. Don't let them catch you. When you think about it, this one's a no solution problem. Does it make sense? Excellent. Now, what if instead of writing it that way, what if they said the absolute value of 4n was greater than or equal to a negative 3? So again, let's think about this. This is a positive number, and this is a negative number. Could this positive number be greater than a negative number? Oh, yeah, it most certainly can. Can it be equal to it? No. No way a positive number can be equal to it. This one you can solve, but you can only solve it as a greater than problem. There's no way it could ever be equal to. Which means you could actually write the positive 4n, right, greater than negative 3. You could also write the negative of the 4n is less than negative 3. Are you with me? All right, so let's work this one out. So I have 4n is greater than negative 3, and that means n is greater than negative 3/4, right? This one, yeah, I'm going to move the negative to the other side. So 4n is greater than positive 3, isn't it? Oops, oops. Did you catch it? Did you catch it? Well, I certainly did, because I wrote something incorrectly in the original problem here. Sorry, guys. Hopefully you caught it. I think some of you did. You're trying to yell at me through the video, and it didn't work very well. Sorry. Go back. We have the positive 4n is greater than negative 3, and we have the negative of the 4n is greater than negative 3. And when I multiply both sides by the negative, I have 4n is less than a positive 3, which means n is less than a positive 3/4. Got it? Okay, so what do you think? Number line, good job. So I'm going to put the number line over here. I have the negative 3/4. I have the positive 3/4. At the negative 3/4, that's all the way to its right, to positive infinity, with a parenthesis. On the other one, it's to the left of the positive 3/4, all the way out to negative infinity, also with a parenthesis. So what do we want? Do we want the overlap, or do we want all the shading? Yeah, this is where the absolute value is by itself. This is red, gray, tor. So it wants all the shading, doesn't it? But remember, it can't be equal to. So, yep, we start at negative infinity, and I'm noticing right here has a parenthesis, which means it can't be equal to the negative 3/4, which means I have to stop at negative 3/4 and put the parenthesis. But then there's shading picking up at the negative 3/4. And it goes all the way to, whoops, I'm noticing at positive 3/4 there's also a parenthesis, which means I have to stop at positive 3/4 and put a parenthesis. And then I get to start the shading picks up again at 3/4, and now it can go all the way to infinity. This answer is an interesting answer. It's basically everything on the number line except for negative 3/4 and positive 3/4. Are you with me? It's basically that, because if I left the equal to sign in, that's where it would have been equal to, and it can't be equal to, because you can't have a positive number equaling a negative number. Again, this was greater than or equal to, so had I left the equal to sign in there, right, I could see that that is where my n, my number, would have made this equal to a negative 3. And you can't have a positive equal to a negative. Can't be equal to. So in this case, I have 1, 2, 3 intervals that are shaded because these parentheses are going to knock out the negative 3/4 and the positive 3/4. Cool? Does that make sense? Yeah, this one you got to pay attention to in terms of the writing for problem number 6. Okay, you have fun with this stuff, and I'll catch you on the flip side.